In this video, we will be discussing reflections. Now, here's the thing you're looking for this time. You're looking for negative signs. So if the negative is in front of the entire function, then that means you're reflecting over the x-axis. In your chart of values, that means that you will take all the y values and you will make them negative, and the x-intercepts will not move. If the negative is in front of the x, not the function itself, in front of the x only, then that means you're reflecting over the y-axis. And in your chart of values, you will change the signs on all of your x coordinates this time. And again, if you're reflecting over the y-axis, your y-intercepts won't move. They will stay exactly where they are. So if we look at this example, and we've seen this example in both of the previous transformation videos, so we can finish off our table of values that we've been using over and over again. +3 and that'd be 0. Okay, so there are the the table of values for that function in blue. Now, if you look here, they want you to graph g of x, which is equal to negative f of x. So that negative in front right there means that we are reflecting over the x-axis. Okay, so we're going to take this and we're going to flip it this way. We're going to reflect it over that x-axis here. So this stuff is all going to come down here, and this stuff down here is all going to come up here. Now in your chart of values, that means that you're going to take each of your y values and you're going to put a negative in front of them all. So when we do g of x, negative of 0 is still 0. Negative of 3 is positive. Of negative 3 is positive 3. 0 remains 0. That would become negative 3, and that would become 0. So notice it's just taking your x. Notice that each time our x-intercepts did not move. They stay exactly where we are. But this triangular piece will now come down this direction, right? Because the +3 now becomes -3, so it gets flipped upside down like that. And then this side will also get flipped upside down. So 1, 2, 3. So rather than being a valley, it'll be a peak. So there is your function g of x in red. So that's my g of x. That is the function in blue that has been reflected over the x-axis. All right, now, if the negative is in front of the x, notice it's not in front of the function, it's in front of the x. So this chart, again, we can fill in the chart of values. We've been using this for the last two examples. So this is 0. This is -4, -2, 0, -1, 5, 0 would be 4, and 4 would be 0. Okay, so there's our table of values. All right, this negative right here being in front of the x, notice not in front of the function, in front of the x, means that you're going to reflect over the y-axis. So what that means is that our y values are going to stay the same. So this is still going to be g of x, but our x's are what's going to change, and we're going to make each of those negative. So the -6 would become +6, the -4 would become +4, the -2 would become +2, then -1 would become 1, 0 would stay 0, and 4 would become -4. So when you're reflecting over the y-axis, you're flipping it this way. So this point is going to stay the same, right? Your y-intercepts are going to stay the same. This is going to come over here. So this line is going to get flipped going this way. So 4, notice, instead of 4, 0, it should be -4, 0. So there's your straight line going this way, right? And then we have to flip this part with the parabola and the straight line. So the straight line here, instead of starting at -6, 0, is now going to be over here at 6, 0. So this and this is going to go that way. That's this little piece right over here. That's going to be over here. And then we need to do that parabola section. So this point right here at -4, -4 is now going to be at +4, -4. So that point's going to get reflected over here. This point is going to get reflected over here. So then you can draw in that parabola part. All right, so it should look like I took this and just reflected it this way over the y-axis. Just took the whole thing and flipped it. So these can get a little confusing with the charts. So just keep that in mind. But when you are doing especially some higher level ones, sometimes the charting really kind of makes it clear if you just do one step at a time, and it's nice to see it all in chart formation. All right, so if you are reflecting, and again, they don't give you the graph, you have to be able to identify the parent. So the parent, the basic function in this is just the absolute value function, right? It's just that. So it would be that V shape, right? Just that we've done this one multiple times. All right, so now we've got g of x is the absolute value of negative x. Whoops, that was weird. I don't know why it drew a little. Let me erase that. There we go. Okay. So that negative right there in front, again, if it's inside the function, that means you're reflecting over the y-axis. So reflect over the y-axis. Again, that's when it's inside the function. So if I reflect over the y-axis, this line would go over here. So this line on the right-hand side would now be this line on the left, and the line on the left would become the line on the right. And notice, there's no difference in the graph. And that's because we're doing an absolute value graph, right? If I take the absolute value of 2, I get the same as if I get the absolute value of negative 2. So it's got this nice symmetry. So this graph, which is symmetric over the y-axis, if I reflect it over the y-axis, it's still going to look exactly the same. So when we talked about those symmetry tests, this is another time where knowing the symmetry will also come in super handy when you are discussing your graphs. All right, what about this graph? Okay, describe how the graph g of x equals negative x can be obtained from one of the basic graphs, and then graph it. Okay, so what's the parent function? The parent function is just f of x equals x, right? That straight line with an intercept of 0 and a slope of 1. Okay, the negative is in front of the function, right? The function is x, we've got a negative x. So this means that we are going to reflect it over the y-axis. So reflect over y-axis. So this part is going to get flipped over here, and this part is going to get flipped over here. So notice that point is going to stay the same. The origin is going to stay the same. But now, rather than having a positive slope, notice now we have a negative slope, which if you look at the equation makes sense, right? That if you look at it in red, that is the equation of a line with a slope of -1 and a y-intercept of 0. All right, so those are your basic reflections over the y-axis and the x-axis. Come back next time and we'll start doing what we call some stretching and some shrinking. Some people call it compressions and expansions. It just depends on what textbook you use. Our textbook calls it stretching and shrinking. So we'll see you next time for that video.